All right, so SpaceX's Starship spacecraft isn't going to be able to make it all the way to the moon. Never mind Mars all by itself. To get into orbit and then continue on its journey, each Mars or moon-bound Starship is going to have to meet up in orbit with its brethren in order to fuel up for the journey beyond Earth. This is a mission that has never been attempted in the history of space exploration. But SpaceX's orbital refueling method for Starship is not only groundbreaking, but also astonishing to the entire scientific and technological world. All will be revealed in today's episode of Alpha Tech. And before we get into the meat of today's content, we want to tell you, first of all, thank you so much for watching this channel these last 3 years. Right now, we're getting very close to the 100,000 sub mark. But to achieve this, we humbly ask for your help. If you're watching these videos every day, make sure you hit that subscribe button, and that way you'll never miss out on any of our exciting content. And it also gives you the motivation to keep creating these videos for you to watch every day. All right, space lovers. Let's continue. The most important fundamental design goal of Starship is full and rapid reusability, propellant being the only thing intentionally expended during launches. However, the overarching purpose of Starship is to support SpaceX's founding goal of making humanity multi-planetary and building a self-sustaining city on Mars. And to achieve this monumental feat soon, SpaceX must first undertake NASA's mission to the Moon. So the company will not only have to build the most easily and rapidly reusable rocket and spacecraft in history, but it also needs to master orbital refueling. Besides the processes of launching and landing rockets, to achieve in-space refueling, Starship needs to meet three critical and essential conditions: docking in space, maintaining propellant at cryogenic temperatures, and transferring the fuel between spacecraft. Each of these challenges must be overcome to ensure the success of long-duration missions beyond Earth orbit. First is docking. This is perhaps the most straightforward of these challenges, given SpaceX's extensive experience with docking operations at the ISS. Starship's refueling operations will involve docking two massive spacecraft in orbit, one acting as the tanker and the other as the depot or mission vehicle. While Starship is larger than current spacecraft, the docking process benefits from the fact that SpaceX controls both vehicles, allowing for precise alignment and engagement systems. SpaceX's history of successfully docking cargo and crew vehicles to the ISS provides a solid foundation for these operations. Next is propellant cooling. This presents a more intricate challenge, particularly due to the cryogenic nature of the fuels involved. Starship uses liquid oxygen and liquid methane, which need to be kept at extremely low temperatures, 90.2 Kelvin for LOX and 112 Kelvin for methane. Maintaining these temperatures in the vacuum of space where heat can't easily dissipate is difficult. The risk is that without proper cooling, the propellant could boil off, reducing the mission's fuel supply. To address this, SpaceX is exploring passive cooling techniques, such as specialized surface coatings and controlled spacecraft orientation to minimize solar heating. Additionally, NASA's research into cryogenic fluid management, including the use of cryocoolers, provides valuable insights. Cryocoolers are advanced refrigeration systems that can prevent boil-off by maintaining the propellant at stable, ultra-cold temperatures, as demonstrated in applications like MRI machines and space missions. Finally, propellant transfer in microgravity is another hurdle. On Earth, gravity naturally separates liquid from gas in a tank, but in space without gravity, propellants tend to float freely, and that makes transfer difficult. To address this, techniques like ullage thrusters are used. These small thrusters create a slight acceleration, pushing the liquid fuel to the bottom of the tank so it can get pumped out effectively. Another proposed method involves cooling the receiving tank so that the pressure difference forces the propellant from one tank to another, a technique NASA has successfully tested in ground-based experiments and partially in space with missions like the Robotic Refueling Mission, RRM-3. NASA's historical and ongoing research into cryogenic propellant management underpins some of the current understanding of these technologies. The RRM-3 mission, flown to the ISS back in 2018, successfully demonstrated long-term cryogen storage. Although a hardware failure prevented the demonstration of in-orbit methane transfer, despite this, the mission validated key concepts needed for orbital refueling, such as zero boil-off storage, and that shows that with continued development, these technologies are going to be viable for future missions. Overall, the technical challenges of orbital refueling are formidable, but not insurmountable. With SpaceX's approach, their rockets can leverage proven techniques while also advancing the level of sophistication in space operations. However, there are still many questions regarding the number of tanker flights needed for the SpaceX Starship missions, with estimates ranging from as few as 5 flights to as many as 20 or more. This variation stems from several factors, including the payload capacity of each tanker, the mass of the lunar starship, and the specific mission requirements, such as the amount of cargo being delivered to the moon or left behind on the lunar surface. While the exact number remains uncertain, what is clear is that the success of this approach hinges on SpaceX's ability to conduct these flights efficiently and reliably. In scenarios where only 5 tanker flights are needed, the refueling process appears straightforward and manageable, even with current technologies. This lower number assumes high efficiency in both payload delivery and propellant usage, potentially achievable if Starship's design meets or exceeds expectations. However, in more conservative estimates, where up to 20 flights may be required, the challenge becomes significantly more complex. Conducting 20 tanker flights within a tight timeline mission demands a high level of operational capability and reliability from SpaceX. Each additional flight introduces more opportunities for delays or failures, which could jeopardize the entire mission. Despite these challenges, SpaceX's strategy of rapid reuse is designed to mitigate the risks associated with a higher number of tanker flights. Starship and its booster Super Heavy are being developed with rapid turnaround times in mind, aiming for a level of reusability that far surpasses any current space vehicle. If SpaceX can achieve its goal of launching and landing the same Starship multiple times within days or even hours, the logistical burden of multiple tanker flights becomes more manageable. For example, in a scenario where 20 flights are required, SpaceX's vision of quick reusability could allow for a launch every few days, significantly reducing the time and cost associated with each mission. Moreover, the economics of SpaceX's reusable launch system are designed to accommodate frequent flights without a proportional increase in cost. The key advantage of this approach is that the cost of propellant, already relatively low, does not scale significantly with the number of flights. Instead, the focus shifts to the efficiency of launch operations, where SpaceX has already demonstrated considerable proficiency with its Falcon 9 program. The ability to launch multiple Starship flights in quick succession could make even a high number of tanker flights feasible, both technically and financially. In the past, at the time the contract for HLS was awarded, competing bidders Blue Origin noted that according to SpaceX's data for Starship, an HLS variant of the vehicle would require the launch of 15 other Starship vehicles to get it to the moon. The first of these would be another modified Starship designed to be an orbiting fuel depot. It would then be followed by 14 further tanker Starship flights, which would only transfer up to 100 tons of propellant per flight for transfer to the fuel depot. Only after these flights had been performed would Starship HLS be launched, and it would have to rendezvous with the fuel depot and transfer the majority of propellants, approximately 1,200 tons, from the depot to its tanks to be able to boost itself to the moon and then break itself into lunar orbit. Despite such claims being made based on SpaceX's figures, Elon Musk poo-pooed them, claiming all such refueling could be done in 4 to 8 flights, not 16. Moreover, as of April 2024, in a public address to all company employees, Elon reaffirmed that you only need 5 to 6 refueling missions for a trip to Mars.
Need about 5 or 6 refilling missions for every one mission that goes to Mars.
Yes, it's even more ambitious than we thought, isn't it? But Elon Musk has his own calculations, and SpaceX can achieve this with Starship variants that can have extended or even expanded fuel tank volumes. Elon also promised, next year we're aiming to demonstrate ship-to-ship propellant transfer. It's hard to make this not look a little bit naughty, because its 2 ships are connected and doing a fluid transfer. On the other hand, NASA understood that it was accepting a degree of risk when it selected Starship as its solitary lunar lander design for Artemis 3 and 4. In the HLS source selection statement, Kathy Lueders, the former leader of the defunct Human Exploration and Operations Mission Directorate, wrote, "I acknowledge the immense complexity and heightened risk associated with a very high number of events required to execute the front end of SpaceX's mission, and this complexity largely translates into increased risk of operational schedule delays. However, the only alternatives were an overweight Dynetics lander and a Blue Origin lander, which would need a substantial redesign to achieve NASA's long-term goal of landing 4 astronauts on the moon. In this context, Starship had a significant upside, as it far exceeded the HLS performance requirements. SpaceX claimed that it could deliver 100 tons of cargo to the lunar surface, which would reduce the operating costs of the Artemis base camp. In addition, SpaceX's $2.9 billion bid was half the price of its competitors' landers, since the company could offset Starship's development costs by also utilizing it to launch satellites. Over the past year, SpaceX and NASA have made noteworthy progress with the development of HLS Starship. The 4 test flights demonstrate that SpaceX is learning dozens of lessons from each mission and gradually improving the rocket's reliability. In February, NASA and SpaceX completed over 200 tests of the docking system, which will mate HLS Starship to Orion in lunar orbit. Leaked renderings demonstrate that the HLS team is factoring all of these test results into a more robust and capable design for the land. The constant activity at Starbase makes people like us feel as if our own lives are just moving in slow motion. Recently, SpaceX secured a beneficial license for the Starship launch, and on top of that, they completed the stacking of the second launch tower in record time. As we move past mid-August, the aerospace community's attention is increasingly focused on early September, the time when Elon previously announced the fifth test flight of the Starship spacecraft. This launch is crucial for the ongoing development of the entire Starship program, marking the first time SpaceX will attempt to catch the returning rocket using Mechazilla, attempting to push the boundaries of rocket technology even further. In a groundbreaking move, SpaceX just received a license from the FCC for the Starship program. The license is valid from now through February 25th of next year. Under the Purpose of Operations section, the agency states launch via communications for the test flight mission launching from Starbase, Texas. The first stage booster will either return to the launch site or perform a controlled water landing. This FCC approval marks a major milestone, essentially giving a preliminary nod to SpaceX's revolutionary booster recovery method. However, the path forward is not entirely clear yet. Now it's the Federal Aviation Administration that still needs to weigh in, and their decision is highly anticipated. Interestingly, despite the absence of a formal mishap investigation from the previous flight, FAA seems to be taking its good old time. This delay could be attributed to the complex nature of SpaceX's new mission profile for their upcoming launch. The concept of catching a large rocket booster with mechanical arms is unprecedented in the history of space travel. If successful, this feat would not only give SpaceX an edge over the competition, but also have the potential to revolutionize the entire approach to rocket reusability. While awaiting that next test flight, SpaceX has been working on the main component of the Super Heavy catch tower, also known as the chopsticks. Booster 14.1 returned to the launch pad August 8th after what I believe was a period spent reviewing the impacts of the previous test back in June. Although it had been on the OLM for a while, it wasn't until August 16th that we saw the first bold test of the chopsticks with its test tank. SpaceX is preparing for a revolutionary step for their fifth Starship flight, ensuring they don't risk a 200-ton booster crashing into the launch pad. This time, the testing process has been upgraded. The Mechazilla arms, aka chopsticks, no longer just move in the air. They now close tightly around the booster with extended landing rails, creating an impressive spectacle. But the most intriguing feature is the new shock absorption mechanism. Imagine giant cushions designed especially for a rocket. The small rail cushions on the arm can extend, acting as impact absorbers when the booster lands. It's a pretty clever solution to counter the massive inertia of a rocket booster plummeting at incredible speeds. Not stopping there, SpaceX continues to test various scenarios. With the chopstick arms fully extended, we witness these dramatic slaps from a powerful single-arm slap to a forceful double-arm slap, causing the booster to shake but stay secure. And the good news is that these vibrations are less violent than in previous tests, indicating that the new design has gotten an upgrade. After a series of tests, the booster was moved to the rocket garden without any visible damage. The coming days are going to be huge for assessing the detailed results of these tests. Whether any changes will be made remains to be seen, but they are unlikely to be that much. Booster 14.1 is laying the groundwork for a historic milestone, the successful catch of Booster 12 during the upcoming fifth Starship flight. And this also serves as a valuable lesson for SpaceX, which they can apply to future Mechazilla towers, especially the second launch tower at Starbase that recently finished its structure. After completing repairs on their special crane, SpaceX quickly finished stacking Module 7 on August 16th. And less than 2 days later, Module 8 got stacked, and by August 22nd, Module 9 was perched atop the tower. This rapid progress showcases just how quickly SpaceX is moving with all this work. Upon closer inspection, one notices a unique aspect of the tower structure. While Modules 1 through 6 each have 3 floors, Modules 7 and 8, they only got 2. The design differs from Tower 1 and the launch tower at LC-39A, where there are 7 evenly spaced 3 floor modules and a top module with only 1 floor. However, don't let this difference fool you. A quick calculation shows that the total height of the tower is unchanged. Only the floor layout at the top has been adjusted. This novel arrangement might stem from some smart technical considerations. The reason behind this change could relate to the construction process. As the tower gets taller, lifting the heavy modules to the top gets more challenging. By reducing the size of the two top modules, SpaceX has given a clever solution, lowering the weight of the sections that need to be lifted to the highest point while still maintaining the necessary overall tower weight. Moreover, we also see improvements in the tower stacking time. It's unbelievable that in just 41 days, less than a month and a half, SpaceX completed the stacking of the second launch integration tower at Starbase. Compared to previous tower builds, this is a big advancement, but this isn't just a speed record. The modules were also constructed potentially 6 to 9 months faster than those for OLIT 1 when it got stacked. Elon celebrated this achievement by sharing stunning images of the second launch tower with the caption, "The Two Towers." However, it also has another meaning that we can understand more deeply. Two Towers, well, that's the second part of the famous trilogy, Lord of the Rings, followed by the third part, Return of the King. Elon's message subtly hints that the massive Starship rocket is akin to a king, suggesting that we are soon going to see the spectacular return of fully reusable rockets. Yes, please. From here, we can see that nothing is impossible for SpaceX. And if I remember correctly, there were times when public opinion did not trust Elon's way of building the tower. But now, take a look at this. SpaceX building the foundation and stacking the tower in nearly 90 days. Too fast and amazing. During this period, there's also doubt about SpaceX's plan to catch rockets using the tower. In the nearly 3 years since Elon first tweeted about the effort to catch the Super Heavy booster with the tower's arms, it's hard to imagine how exactly it could be done. But just for that reason, it was worth SpaceX going through all this trouble to build this amazing machine. They devised a method to land the Falcon 9 rocket vertically on its legs, a feat no other aerospace company has done, even after its initial success. Back in 2015, the first stage of Falcon 9 made history by landing perfectly on solid ground at Cape Canaveral, a milestone never been done before. Just a few months later, April in 2016, the first stage of Falcon 9 hit another groundbreaking moment by successfully landing on a drone ship positioned in the ocean for the first time. Why does SpaceX even want to do these things even though they're already at the top? Elon clarified it on December 30th, 2020, responding on X as he often does when asked if Super Heavy would land like a Falcon 9. Elon replied, "We're going to try to catch the Super Heavy booster with a launch tower arm, using the grid fins to take the load." Well, people speculated the booster would be too tall and heavy for legs. Elon explained, legs certainly work, but the best part is no part. The best step is no step. In essence, he's saying they could take the easy route, but he's intentionally choosing the more challenging path, and there's good reason for this. Elon added, saves mass and cost of legs and enables immediate repositioning of the booster onto the launch mount, ready to refly in under an hour. If the Super Heavy were to land on the pad like the initial Starship tests, bringing it back to the launch mount, even if nearby, would be a big undertaking. It would require a mobile crane and the large tank tread transport vehicle used at Starbase for rocket movement. The process involves the crane lifting the booster, placing it on the transport, moving the entire setup to the launch mount, using the crane once more to return the booster to the mount, and then driving both machines back to the hangar. Landing legs are not only heavy, expensive, and complex, but they can also be fragile and require a lot of maintenance. For instance, Falcon 9 comes down with a lot of force, and although SpaceX uses a crumple zone called crushed cores in the legs to absorb the energy, they still need replacement after each landing. While this isn't a big problem for Falcon given the refurbishment needed for kerosene-burning engines, for Starship and Super Heavy designed for rapid reusability and clean-burning methane engines, can't afford the time for inspections and leg refurbs, especially at Elon's envisioned launch cadence of 3 launches a day per booster. So that's why Elon built the launch tower. It was just his way of taking rocket engineering to the next level, and also making Starship construction even cheaper, even renewable, used more and more effectively. As SpaceX is gradually moving towards launching the final prototypes of the Starship V1 version of the rocket, the curiosity of most space enthusiasts is now focused on the Starship V2 version, an upgraded version promising design changes that will optimize many functions for future launches. Kicking off this new version is Starship 33, which has been quite busy with activities in the Megabay. Ship S-33 marks a significant transition in the Starship program. Initially, it was intended to just be the first second-stage prototype of the V1 version, but was later converted to the new V2 version. This resulted in a unique situation where S-33 has or will have 2 versions of most of its parts, a V1 version, then a V2 version. The assembly of S-33 started July 13th when the V2 payload bay was brought out for stacking. Notably, at this time, the bay did not have a door. The next day, the V2 nose section was brought out and stacked on top of the payload bay. July 22nd, after getting moved to the high bay, the new payload bay door was installed, and 2 days later, the entire stacked payload bay and nose section were moved to the PEZ dispenser installation stand in Mega Bay 2. This stand's been put in place since July 19th. Work continued through August 24th when the top section of Ship 33 was officially installed onto the tail section that had been moved in earlier that afternoon. It's fascinating to watch these stacking activities in MB2. They could easily close the doors for this, but it's cool that they keep it open during these times. So, essentially, Ship 33 was completed August 24th. In total, the assembly process of S-33 took 41 days from the start of stacking the nose section and payload bay and the high bay on July 14th to completion in Mega Bay 2 August 24th. This assembly process highlights the complexity and scale of the Starship project. The transition from V1 to V2 design during production requires considerable flexibility in manufacturing and assembly processes. It also reflects SpaceX's rapid, iterative approach to developing and improving its vehicles. Just think, what other company could use a little over a month to build at least one rocket? Only SpaceX. Of course, this is certainly not the final form of Ship 33, as it still lacks the Raptor engines, which will certainly be the newest Raptor 3 engines we recently saw at SpaceX's production facility. One pretty cool thing we saw was while monitoring the assembly of Ship 33 was the appearance of something new, possibly an internal change in the Starship V2 variants. The first sign is 3 shiny tubes running along the edge. When we zoom in, they look like small transfer tubes. This seems like an essential component that needs to be specially produced for the tanks, known as a downcomer. Each rocket needs at least 2 main tanks, one for propellant, one for oxidizer. Due to the tall cylindrical shape of the rocket, one tank sits above the other. The bottom tank directly supplies the engine right below it, while the top tank needs a way to feed fuel down to the engine. This is usually done via a downcomer, which runs through the center of the bottom fuel tank, then connects to both the engine and the upper fuel tank. Interestingly, the downcomer of Ship 33 we see is completely different. Why are there 3 tubes? Perhaps this is the design for the second version of Starship, with each tube separately delivering methane to 3 vacuum engines. As for the large brown cylinder in the middle, it looks too heavy for a flight device, right? However, this could easily just be a support structure, helping to lift the entire system into the tank more easily during install. Inside this seemingly rusty support cylinder could be a thicker downcomer used to supply fuel to all 3 sea-level Raptor engines at the same time. Having separate tubes for each vacuum engine would allow for better propellant stability and earlier warning if any tube runs dry. This change could be related to the new 3 Raptor engines, which will be equipped on the second stage ships. The Raptor 3 consumes fuel faster than any other Raptor engine, requiring a faster fuel supply. This new design might be aimed at delivering more fuel to each engine, increasing thrust. It could also address issues with propellant stability, although this has never been a problem on previous ships. It seems like Raptor 3 is so advanced that even the ship needs to be upgraded to match. This is a promising step forward, showing the Starships being increasingly refined and perfected. We might wonder why the upper part of the central tube is much lower. Remember the strange funnel hanging down from the common dome we saw last week? It'll hang much lower to connect with this tube. These are interesting changes alongside the external changes we already knew about. For those who might have forgotten, the differences currently observed on S-33, which are expected to set the standard for future V2 ships, include but are not limited to, first, a shorter payload bay. The reduction from 5 to 3 rings for the payload bay is a big change. This, combined with the addition of 1 ring to the V2 body, results in a total of 3 additional rings for propellant. This change indicates SpaceX is prioritizing increased fuel capacity, which could be aimed at extending range or enhancing the ship's payload capacity. Secondly, new flaps. The new forward flap design is related to improving aerodynamics or control during re-entry. This will also help increase the landing precision or enhance heat resistance. Next is the new thermal protection system. This is a completely new manufactured heat shield that doubles durability, and beneath this layer of tiles is an ablative material layer. Lastly, the installation of the PEZ dispenser. Installing the PEZ dispenser after the nose cone and payload bay are stacked due to the PEZ dispenser being partially inside the nose cone also makes more efficient use of space in addition to the aforementioned propellant increase. We are really looking forward to when SpaceX is ready to test what's believed to be the upgraded version of the Starship. When do you think they'll start testing S-33? Let us know down there in the comments. While Starbase is busy, the Florida missions with Falcon 9 also have no time to rest, especially Polaris. This private mission of a billionaire in collaboration with SpaceX will be the first to perform a spacewalk at a record-breaking altitude in history. The mission is scheduled to launch early Tuesday morning, sending 4 people to orbit for 5 days aboard a Crew Dragon spacecraft. This quartet will go farther from Earth than any human since the Apollo days, and 2 of them are going to do the first spacewalk ever conducted by a private mission. Here's a summary of what to expect during the spectacular Polaris Dawn spacewalk, which you can watch via SpaceX's webcast. The spacewalk, or extravehicular activity, EVA, will take place on the 3rd day of the mission. SpaceX and the Polaris Dawn team have not yet announced the target time. The EVA will feature 2 of the 4 crew members, Commander Jared Isaacman, the billionaire tech entrepreneur who funded and organized Polaris Dawn, and mission specialist Sarah Gillis, an engineer at SpaceX. But the other 2 astronauts, mission specialist Anna Menon, also a SpaceX engineer, and pilot Scott Kidd Petit, a former lieutenant colonel in the U.S. Air Force, will don their EVA suits as well. That's because Crew Dragon doesn't have an airlock, so the capsule's interior will be exposed to the vacuum of space. The entire EVA operation, from initial venting to the repressurization of the capsule, take about 2 hours, Isaacman said during a press conference last Monday. The actual spacewalking component will comprise perhaps a third of that time. According to mission team members, Isaacman and Gillis will spacewalk sequentially, not together, and each will likely spend 15 to 20 minutes outside the capsule. Isaacman said that both crew members would fully exit Crew Dragon, but don't expect anything too fancy or dramatic like Ed White's iconic spacewalk in 1965, the first ever EVA by an American astronaut, during which White dangled far away from his Gemini capsule on a 23-foot-long tether. The Ed White photo is historic, but I think, as you know, Buzz Aldrin told us that's not the way to do an EVA, Isaacman said on Monday, adding he and Gillis will always aim to maintain at least one point of contact with the mobility aids that SpaceX made for the mission. We're not just going to be up there floating around, he said. Isaacman and Gillis will tick off a number of milestones during their time outside Crew Dragon. It'll look like we're doing a bit of a dance, and that's what it is. We're going through a series of test matrix on that suit, Isaacman said. The idea is to learn as much as we possibly can from the suit and then get it back to the engineers to inform future suit design evolutions. Indeed, the EVA suits, which SpaceX developed in-house, are not one-offs for Polaris Dawn alone. The company intends to use them, or future versions of them, on a variety of missions in Earth orbit and beyond. It's not lost on us that, someday it might be 10 iterations from now and a bunch of evolutions of the suit, but that someday someone might be wearing a version of that which might be walking on Mars, Isaacman said. And it feels like, again, a huge honor to have that opportunity to test it out on this flight. Polaris Dawn is the first of 3 planned missions in the Polaris program, which Isaacman is both organizing and funding. If all goes according to plan, the 3rd Polaris flight will be the first ever crewed mission of Starship, the enormous vehicle that SpaceX is developing to help humanity settle the Moon and Mars. Old, expensive, and complex are relics of the past. Meanwhile, new, affordable, and efficient are hallmarks of progress. This contrast is epitomized by the Starship and Space Shuttle. The latest advancements in Starship's heat shield and welding techniques have not only surpassed, but arguably embarrassed NASA's shuttle in terms of innovation and effectiveness. Although it's undeniable that the Space Shuttle was an iconic symbol of the U.S. for over 3 decades, by the time Starship came out, the Space Shuttle had become just a name. It's not an exaggeration to say this, because with SpaceX's rapid development to a level that's just impossible to ignore, it's not going to be long before they attain perfection. However, even as they gradually improve their technology, SpaceX has managed to embarrass NASA with their advancements in heat shield and welding technology. First, let's talk about heat shield technology. When the Space Shuttle or Starship was being developed, special insulating materials had to be created to protect the spacecraft and astronauts from the extreme cold temperatures of space and the intense friction forces during reentry, and that can cause temperatures at certain points to rise to about 3,000 degrees Fahrenheit. The solution from both NASA and SpaceX was a combination of materials known as the Thermal Protection System, or TPS for short. However, for a TPS to work effectively, it needs to be integrated with several different factors. One of the key being to make SpaceX's Starship heat shield superior to NASA's Space Shuttle, and that is, first and foremost, through the shape of the spacecraft. Starship's significant dimensions result in a larger radius of curvature during reentry, which in turn pushes the intense heat generated by the shockwave further away from the vehicle's surface. This reduces the thermal load on the spacecraft, making it easier to manage the extreme temperatures encountered as it comes back to Earth. A bigger spacecraft can distribute heat more effectively, lowering the risk of localized hotspots that could lead to structural damage. Another advantage of Starship is just simpler geometry. All versions of Starship have a uniform cylindrical shape, and that allows for easier application of the heat shield tiles. On the other hand, the shape of the shuttle had to be set up so it could glide like an airplane, as well as act like a lifting body while falling through the upper atmosphere. Therefore, it had a complex curvature in all three dimensions. There were a large number of things: control surfaces, wheel wells, radio antennas, inspection hatches, sensors, and so forth that had to penetrate through the heat shield, and this added some complications. Worse still, to keep that weight low, they used thinner tiles where the heating was less, and in places of extreme pressure, like the leading edge of the wings, they used heavy, molded, reinforced carbon-carbon sections instead of tiles. There were four different kinds of tiles with acronyms HRSI, FRCI, TUFI, and LRSI, and three more kinds of insulation that were not tile-based for upper surfaces: FIB, FRSI, RCC, FRSI. And then finally, there were gap filler strips that were wedged into gaps for wheel wells and such, which would fall out when the wheels were lowered. The end result was that no two of the 31,000 tiles on the shuttle were of the same shape, type, or thickness. Every single tile had to be manufactured specifically for its location. As you can see in the photo, they were all individually numbered, and a vast number of people were employed to install, inspect, and replace broken or missing tiles. Some kind of tiles were extremely fragile, and if you dropped one or even just put a little too much pressure on it to put it into place, you could damage it, and a new, unique copy of the tile would then have to be manufactured. As a consequence, even the best tile installers could only manage to install about 2 tiles a week. Wow, talk about slow. If a critical tile were lost while in orbit, there's no possibility of carrying a replacement tile and fixing it up there in space because they were all different. Of course, it can't be denied that SpaceX's modern engineering methods are among the most advanced. Most of the surface of Starship is covered with identical hexagonal tiles, which simplifies the manufacturing process, especially since they're attached automatically, making any repairs way quicker and cheaper. Of course, there are certain areas where smaller or more curved hexagonal tiles are needed, but their number is insignificant compared to the total of 18,000 heat shield tiles. The tiles are deliberately installed with small gaps between them, and they're designed to expand to fill those gaps as they're heated upon re-entry. Gaps between the tiles are also well tolerated because of the small amount of remaining propellant in the fuel tank cools the steel beneath and uses a hexagonal pattern rather than the more rectangular arrangement on the shuttle, and that prevents jets of superheated air following a straight line path between a row of tiles. Replacing a damaged or missing tile can be done in a matter of minutes by a guy on an elevating work platform. They also clamp the tiles onto small steel pins welded to the rocket's frame to increase their sturdiness, rather than relying solely on adhesive like NASA's space shuttle. As for the placement of the heat shield tiles, the shuttle tiles were much more vulnerable than those on Starship because they were put side by side with a huge tank operating at cryogenic temperatures, which was covered in foam that was prone to detaching. This meant that the shuttle tiles were often hit with big chunks of ice and frozen foams that could break large numbers of them. Starships put atop the booster, and the tanks don't reach such low temperatures, so no foam is used and ice formation is less likely. And if it does, it's not going to hit the tiles. Besides, Starship's use of stainless steels for its construction also gives thermal benefits. Stainless steel has a much higher melting point and better heat resistance compared to the aluminum used in the space shuttle structure. This allows Starship to endure higher temperatures without the need for an overly complicated thermal protection system. The material also gives structural strength, enabling the spacecraft to withstand the stresses of launch and re-entry with less risk of deformation or damage. Meanwhile, the shuttle's thermal protection system requires meticulous inspection and frequent tile replacements after each flight due to the vulnerability of its aluminum structure. Aluminum can lose half its strength at temperatures around 200 degrees Celsius and can rapidly and catastrophically melt when exposed to excessively high temps. Starship, on the other hand, well, that's made of stainless steel, and that can withstand temperatures of around 700 degrees Celsius before losing half its strength. This makes the issue of thermal protection a lot easier to manage. Starship's heat shield's pretty impressive, and that's not all. Recent improvements by SpaceX and Elon have made it even better. After Starship's 4th launch, Elon decided to replace the entire old heat shield with a new one that's twice as durable. While the exact composition of these new tiles is unknown, it's likely that they are made from a type of ceramic matrix composite, CMC, similar to the old TUFROC tiles, but with new materials added to enhance durability. These new tiles are often prone to cracking or detachment. Additionally, Elon's introduced a new ablative material placed right under the new heat shield tiles, though only in key areas that are likely to get exposed to those extremely high temps. This helps Starship maintain its weight while still providing effective thermal protection. It's not just Starship's heat shield that might embarrass NASA. The Starship's welding also sticks out. Recently, an OIG report highlighted welding joints that failed to meet NASA's specifications. According to NASA officials, the welding issues arose from Boeing's inexperienced technicians and inadequate planning and oversight of work orders. The lack of trained and skilled workforce increased the risk that Boeing will continue to produce parts and components that don't comply with NASA's requirements and industry standards. We can't put all the blame on Boeing, but NASA engineers overseeing this rocket mission must also bear some responsibility. In fact, welding issues related to the core stage of the SLS were made public as early as October of last year, and it's unclear why these issues have not yet been fully fixed. So when comparing SpaceX's Starship's welding to others, no one can match its quality, not even SLS. Currently, you can see Starship spacecraft that are sleek, smooth, and shiny. Of course, the welds are visible, but compared to earlier versions, this represents tremendous progress. To achieve this, SpaceX has gone through many different welding techniques. Initially, SpaceX used flux core welding for the construction of early Starship prototypes. This method, while effective for basic structural assembly, had limitations in precision and resulted in welds that were prone to cracks and corrosion. These issues were compounded by the fact that the welding was often performed by welders without specialized rocket experience, leading to inconsistent quality. To address these issues, SpaceX transitioned to tip-TIG, tungsten inert gas welding, a more advanced technique that allowed for cleaner, deeper welds with less warping. Tip-TIG welding provides greater control over the welding process, reducing the risk of defects and enhancing the overall structural integrity of the spacecraft. Further innovation came with the adoption of laser welding, which SpaceX uses for many sections of the Starship. Laser welding offers precise control over the heat input, allowing for deep penetration into the metal with minimal distortion. This technique enables entire segments of the Starship to be welded in just a single pass, significantly speeding up the construction process while maintaining high standards of quality and consistency.
NASA has decided that Butch and Sonny will return with Crew 9 next February, and that Starliner will return uncrewed.
Yes, this is the exact final decision made by NASA by their agency's administrator, Bill Nelson, regarding the fate of the failed Starliner spacecraft and the two astronauts stranded on the ISS. Once again, Dragon is NASA's savior. Fortunately, the decision was made just as space enthusiasts like you and I had hoped. The two astronauts deserve to have their safety assured rather than being put in a dangerous situation up there in space. On August 24th, an official review was conducted to determine whether NASA considers Boeing's Starliner spacecraft safe enough to return home with the crew, or if SpaceX's Crew Dragon spacecraft will need to step in to help the situation. This is an issue that NASA has been talking about for several weeks since the problems with the Starliner have increasingly shown clear consequences. Although Boeing had previously attempted tests to identify the root cause of the issues, it appears that even with additional time, they were unable to gather more data and the situation could have gotten worse. After conducting a test to disassemble and recreate the faulty thrusters of Starliner, NASA felt genuinely concerned. According to Steve Stitch, their director of the Commercial Crew Program, he said, "I would say the white sands testing did give us a surprise. It was a piece of Teflon that swelled up and got into the flow path and caused the oxidizer to not go into the thruster the way it needed to. That's what caused the degradation of thrust. When we saw that, I think that's when things changed a bit for us." So, when NASA presented this finding to the thruster manufacturer, Aerojet Rocketdyne, the thruster company said they'd never seen this phenomenon before. At this point, the agency's engineers began to accept that they were not confident enough in the physics to be certain that the thruster issue would not happen during Starliner's return to Earth. Ultimately, the decision was made for Boeing's Starliner to return to Earth unmanned, and the two astronauts who took the spacecraft into orbit during the test flight would come back in a capsule manufactured by a competitor, SpaceX, despite previous assurances that Starliner was going to complete the mission. This means that SpaceX's Crew 9 mission will now be reconfigured to carry 2 astronauts instead of 4. This adjustment will leave 2 empty seats for Williams and Wilmore on the Crew 9's return flight. The astronauts will also join the Crew 9 team, becoming part of the official ISS expedition. With this transition, Williams and Wilmore will stay an additional 6 months, the duration of a regular mission to the space station. The shift to Crew 9 will push the pair's return to as early as February 2025. In response to this news, SpaceX's CEO Gwynne tweeted on X, "SpaceX stands ready to support NASA however we can. As for Elon, He didn't comment on the matter. Instead, he shared a story titled Re-Entry by renowned journalist Eric Berger, which discusses the development of Crew Dragon in competition with Starliner and NASA's secret meeting where SpaceX almost got excluded from the Crew contract. This reflects his pride in his spacecraft and his desire to show everyone just how crucial SpaceX's presence is to the space industry these days. The latest result from NASA will be a significant blow to Boeing. 10 years ago, SpaceX was looked at with skepticism, like they were space cowboys or something. For 15 years in the space industry, Boeing was regarded by many in the industry as the aristocracy of space travel, while SpaceX was seen as the company that was going to kill astronauts due to its alleged recklessness. Now the space agency is asking SpaceX to rescue Boeing astronauts currently on the ISS. This isn't the first time SpaceX has recently helped out a competitor. In the past 2 years, SpaceX has launched satellites for a competitor in low Earth orbit internet, OneWeb, after Russia's space program tightened control over the company. They've launched Europe's Galileo satellites after the Ariane 6 rocket got delayed, and they've launched the Cygnus spacecraft, built by NASA's other space station cargo service provider Northrop Grumman, multiple times. Now, SpaceX is going to help Boeing, a competitor in crewed missions. So, what about the fate of Starliner after it returns? In the latest meeting, NASA stated that if the uncrewed return goes well, they will face an important decision, whether to officially certify Starliner to carry humans into space, a step that would allow the spacecraft to perform regular flights to orbit, even though the fact remains that it did not complete the mission as planned. In a statement on Saturday, Boeing said it continues to focus first and foremost on the safety of the crew and spacecraft. We are executing the mission as determined by NASA, and we are preparing the spacecraft for a safe and successful uncrewed return. Steve Stitch said Saturday that there was a little disagreement between NASA and Boeing in terms of the level of risk. It depends on how you evaluate the risk, Stitch said. We did it a little differently with our crew than Boeing did. Nelson later added that he's 100% sure that Boeing will address the issues and set up Starliner for another crewed mission at some point down the road. But in reality, don't expect another crewed flight with Starliner next year. NASA officials said on Saturday that it's still too early to decide whether the agency will require Boeing to conduct another test flight with the Starliner spacecraft or whether Starliner can get put into operation after Boeing fixes the issues with the spacecraft's propulsion system. Currently, NASA has not decided whether to classify the situation involving the Starliner crew test flight as an accident or mission failure. Making such a decision could potentially lead to a more formal independent investigation, which could delay Starliner's next flight under any circumstances. One factor that could further complicate the investigation related to propulsion is that the thrusters are located on Starliner's service module, which will burn up over the Pacific Ocean when the spacecraft returns, preventing any further inspection or data collection. Assuming the investigation does not uncover any additional issues, and NASA and Boeing decide to bring Starliner back into operation with astronauts in 2026, the remaining time for the space station as currently planned would not be enough for Starliner to complete all 6 missions under the contract at a rate of 1 mission per year. It's hard to imagine that NASA would decide to use only Starliner to send astronauts to the space station, especially considering SpaceX's success and the fact that NASA has contracted SpaceX for crewed missions through the end of this decade. Hopefully that will not happen, because if there are no more serious problems with Starliner's launch, we've already grown too weary of all of Boeing's mistakes. For example, the first Starliner test mission, flown in 2019 without a crew, misfired in orbit and cut the flight far short of expectations. The vehicle did not ultimately dock with the space station as intended, and the outcome was revealed to be a symptom of a myriad of software problems, including a coding error that set an internal clock off by 11 hours. A second uncrewed flight test in 2022 uncovered additional software issues, and the mission teams addressed the problems with some of the vehicle's thrusters. However, the root cause of the thruster trouble plaguing the crewed mission got missed 2 years ago. Whether Starliner's vehicle ultimately becomes certified after its return to Earth will likely become a controversial issue, which is considered to be the most dangerous leg of the mission. The autonomous vehicle will have to use its thrusters to precisely orient itself as it plunges back into the Earth's thick atmosphere. The pressure and friction are expected to heat the vehicle's exterior to roughly 3,000 degrees Fahrenheit. Starliner's parachutes then have to deploy without issue and slow the spacecraft before triggering airbags to expand and cushion the landing. If Starliner capsule is ultimately certified, it could join SpaceX's Crew Dragon in making routine trips to the space station to rotate staff. If the spacecraft's denied certification, however, it would mark yet another blow to Boeing's already badly damaged reputation. Missing the mark could cost the company many millions of additional dollars, on top of roughly $1.5 billion that the company's already recorded in losses on the Starliner program. All of us really wanted to complete the Boeing Starliner test flight with the crew, and I think unanimously we're disappointed not to be able to do that, Bowersox, associate admin for NASA's Space Operation Mission Directorate, said. But you don't want that disappointment to weigh unhealthily in your decision. Boeing's cost overruns have spurred recurrent rumors that Boeing may not see the Starliner program through. Nelson said Saturday, however, that he recently spoke with Boeing's new CEO, Kelly Ortberg, about Starliner's status. I told him how well Boeing worked with our team to come to this decision, Nelson said, and he expressed to me an intention that they'll continue to work on the problems once Starliner is back safely and we have our redundancy and our crewed access to the space station. It is not yet clear, however, who's going to shoulder the cost of the additional testing and development that may be needed to get Starliner development to the finish line. Nelson on Saturday reiterated that its deal with Boeing is a fixed-price contract, which means it's designed to be a one lump sum and then payments don't grow with delays as they do with alternative contracts, such as Cost Plus. However, Nelson added that discussions about how Boeing's willing to pay for the additional testing were not part of his conversation with the CEO. I don't have the answer to that, nor do I think I would have the answer, Nelson said. An unprecedented breakthrough in the history of space travel is about to happen. Next Monday morning, SpaceX embarks on its boldest mission yet. For the first time, 4 ordinary citizens, not professional astronauts, will undertake a spacewalk mission by flying into space aboard SpaceX's Crew Dragon. This flight marks a huge milestone in opening the doors of space to all of humanity. But how will it unfold? What risks await the crew? And how is SpaceX ready to ensure they're safe? First SpaceX spacewalk mission launches in a week. This will be epic, Elon proudly declared while sharing the latest announcement about the launch, which is sure to bring us new surprises. Of course, it all has its reasons. First announced in 2022, Polaris Dawn is the first experimental and developmental mission in a series of 3 under the Polaris program, which Isaacman has stated will undertake and fund in collaboration with SpaceX. The crew includes billionaire Jared Isaacman, a retired Air Force pilot, Scott Kidd Poteet, and 2 of SpaceX's top space operations engineers, Anna Menon and Sarah Gillis. The flight's scheduled for the morning of August 26th, and as of this video, that's only 4 days away. While previous space missions funded by wealthy entrepreneurs might conjure up images of self-indulgent joyrides, Polaris Dawn is an experimental mission designed to push those boundaries. The ultimate goal of Polaris is to take the first steps towards validating the technology that SpaceX will need someday to send humans deeper into space, including setting a record for Earth orbit altitude with an apogee of 1,400 kilometers, conducting the first commercial spacewalk using extravehicular activity EVA suit designed by SpaceX, demonstrating Starlink technology aboard the Dragon, conducting about 40 experiments from 20 partner research institutions. So after launch, the Polaris Dawn crew will take an elliptical orbit extending up to 870 miles from Earth. This takes them deep into the inner region of the Earth's Van Allen radiation belt, which starts at an altitude of around 600 miles. According to NASA, the belt's an area where high-energy particles from the sun are trapped and interact with the Earth's atmosphere, creating 2 dangerous radiation belts. Almost immediately after getting into space, Polaris Dawn crew will begin the process of pre-breathing to prepare for the spacewalk. It's kind of like what divers do to avoid decompression sickness, also known as the bends. Crew members must purge nitrogen from their blood so that when the Dragon capsule is depressurized and exposed to the vacuum of space, gases don't form bubbles in their blood, a potentially fatal condition. We don't have an airlock on this mission, Gillis said, referring to the areas on board the ISS that serve as decompression chambers for astronauts heading out for a spacewalk. Polaris Dawn will instead take a really novel and different approach to the pre-breathing processes that involve slowly decreasing cabin pressure and raising oxygen concentration. Gillis, the lead engineer for space ops at SpaceX and the person who trained the Inspiration 4 crew for their mission, mentioned that this process would take about 45 hours, close to 2 days, unlike any pre-breathing process on the ISS. Eventually, on their 3rd day in space, Polaris Dawn crew will open the hatch of the Crew Dragon when they're about 435 miles from Earth. All 4 crew members, along with the entire interior of the spacecraft, will be exposed to the vast emptiness of space. However, only Isaacman and Gillis will actually step out of the spacecraft, tethered by a few umbilical cords. From beginning to end, Polaris Dawn will expose the crew to greater risks than other orbital space tourism missions, including SpaceX missions that transport paying customers to the ISS or orbit Earth at an altitude of around 250 miles. The biggest difference between the Polaris Dawn mission compared to other missions is that it will feature the first private spacewalk. For more than 2.5 years, SpaceX and the Polaris Dawn crew have been prepping for this mission, overcoming numerous challenges. To better understand, NASA spent many years trying to find a viable replacement for the old, bulky white spacesuit used on the ISS. However, Reisman noted that SpaceX's suit does not include primary life support systems, or the PLSS, which is essentially a backpack that allows the ISS astronauts to float more freely in space to do those complex tasks like repairing and replacing hardware outside the station. Instead, Polaris Dawn crew receives life support from long tubes that are connected to their spacecraft. Then there's the issue of the Crew Dragon itself. To ensure the spacecraft's avionics systems, or the electronics used for navigation and communication, could survive the heavy radiation environment encountered during the Polaris Dawn mission, engineers actually strapped many of the avionics systems to a stretcher and took them to a cancer lab, Isaacman said. Isaacman mentioned that the SpaceX team bombarded the avionics with radiation until they failed, in order to precisely determine when and how this technology might break down. Let's hope it doesn't. According to Menon, when the Crew Dragon spacecraft is exposed to the vacuum of space, components inside the spacecraft might release toxic substances, a natural characteristic of some materials used to make various parts when the cabin is repressurized after the spacewalk. To prevent that, Crew Dragon and many hardware components on the vehicle underwent a pre-flight baking process. This means that it reduced a lot of those toxic substances before the flight, said Menon, a leading space operations engineer at SpaceX who will also serve as the crew's medical officer. This baking process involved placing the vehicle in a high-temperature vacuum chamber, allowing the hardware to release toxins before the flight. According to Menon, SpaceX also deployed an automatic restart software, which can fix computer malfunctions that might occur due to radiation without human intervention. So, how did SpaceX manage to minimize risks for the mission as much as possible? Of course, carrying out such a novel mission in under 3 years is extremely fast by aerospace standards. Going faster is not necessarily more risky, Reisman, a former NASA astronaut, said, referring to the rapid speed of development and extensive ground testing that SpaceX has carried out. Taking large risks in testing when the consequences of failure are low results in reduced risk later when the consequences of failure are high. But you should be nervous about this mission, he added. Anytime you try something for the first time, there are going to be risks. I'll feel much better when they're back inside with the hatch closed and locked after the spacewalk. SpaceX teams tried to mitigate risks and prepare for every potential challenge through a barrage of tests. Some as simple as putting a handrail into a freezing chamber set the negative 90 degrees Celsius to see how cold to the touch a ladder might be when exposed to space, Isaacman said. They even took the spacesuits to a testing site at White Sands Missile Range in New Mexico. There, the suits were struck by small pieces of debris traveling at orbital velocities to see how they could withstand the micrometeorites and avoid punctures that would endanger the crew, according to Isaacman. Objects in orbit around Earth travel at more than 17,000 miles an hour. Adding to the pressure to perform a perfect spacewalk is the fact that time will be extremely limited because the crew's going to have to lean heavily on oxygen supplies during the pre-brief. We got 5-6 days. Maybe you can stretch it of life support on the vehicle, Isaacman said. So you have to really be sure where you have fault tolerance and redundancy in your systems. You got to be sure about the weather for the splashdown to Earth. Speaking to the challenges the crew will face, Isaacman added, sure, there's more risk in a development program than going to and from the ISS, but not a lot more risk, and some risks are just frankly unavoidable. Isaacman said that while he and Gillis in turn won't be free-floating outside the spacecraft, he said they'll fully exit the vehicle during the spacewalk. He said during the operation, they will be well above where the hatch is. We have a hands-free demonstration where it'll only keep our feet engaged in a mobility aid. And we're not just going to be floating around, Isaacman said. It takes a lot of effort to move in a suit when it's pressurized. What really looks like heavy clothing becomes super rigid when pressurized. So you want to be very deliberate in your movements. You want to make a good use of mobility aids. Gerstenmaier, who came to SpaceX following a decades-long career at NASA, said it's been a fun process creating the suits and now being on the cusp of seeing them used in practice. He described the process as leveraging knowledge from NASA, and then we push it a little bit further in other areas, making sure to share lessons learned along the way. This pace of development that we get to do at SpaceX is very much like the development that was required back in the early Apollo days, Gerstenmaier said. We're getting a chance to do that again, where we're really starting to push frontiers with the private sector and learning new things that we would not be able to learn by staying in the risk-free environment here on Earth. It's time to go out. It's time to explore. It's time to do these big things and move forward. Boeing Starliner? Nothing more than a joke. Its first crewed test flight not only failed to achieve its goal, but it's left 2 astronauts stranded in space. So what's the real reason that caused all this? Has NASA finally realized SpaceX's Dragon is a gazillion times better than Starliner? While there have been many articles covering NASA's poor management and the handling of the issues, what we should be more concerned about is the disaster caused by Starliner that has left 2 astronauts stranded on the ISS. As the head of a major aerospace company, Elon Musk is always concerned with such matters. He replied, "True," in a tweet on X. Why is there not more media attention to this debacle? I have a hunch that companies involved were in reverse positions, SpaceX in trouble with Boeing coming to the rescue. This would be the leading news story every day. That's true. Even a minor issue with one of SpaceX's uncrewed projects gets a ton of attention from the company, let alone a manned mission that's been delayed for this long. However, to date, what we're seeing more are the silences as the involved agencies like NASA and Boeing are forced to make game-changing decisions. The silence about the astronaut situation and the core issues that caused the incident is becoming more and more noticeable. And this largely reflects the differences between Boeing and SpaceX. SpaceX, under the dynamic leadership of Elon Musk, has built an image of a groundbreaking, innovative company willing to take calculated risks. This management style, combined with the significant success of the Dragon spacecraft in NASA's Commercial Crew Program, has helped SpaceX become a focal point of media and public attention. On the other hand, Boeing, with its long history and more traditional approach, is often less transparent, even when facing challenges like those encountered with Starliner. This highlights the growing shift in the aerospace industry, where emerging companies like SpaceX are challenging traditional contractors like Boeing. On the other hand, there are legitimate reasons why Boeing's being cautious with its updates. First, it's due to underperforming Starliner itself. To be honest, the issues with Starliner are not unfamiliar to us. In fact, it's faced numerous problems from tests in 2019, 2020, and 2022. This raises the question of whether Boeing's pushing forward with the spacecraft despite not fully resolving past issues. Of course, this would be a barrier to Boeing being comfortable with publicly disclosing the root causes of Starliner's failures. In contrast, SpaceX's Dragon has been highly efficient, successfully sending over 53 astronauts to the ISS. It's not that Dragon hasn't faced issues, but the swift handling by SpaceX's engineering team is evident as Dragon continues to launch regularly. Secondly, being open is difficult for Boeing due to the differing visions and motivations of the two giants in the space market. Boeing's got a solid reputation and has developed close relationships with government agencies like NASA. However, this can also lead to a mindset focused on maintaining contracts and maximizing profits from government-funded projects. This approach, while ensuring financial stability, may reduce the drive for innovation and risk-taking. In contrast, SpaceX, founded with Elon's personal vision of colonizing Mars, represents a new business model in the industry. Their motivation is not just profit, but also achieving major goals in space exploration. The difference is evident in how the two companies approach their projects. SpaceX often sets higher goals, embraces failure as part of the learning process, and quickly adapts based on results. Boeing, with its more traditional corporate culture, tends to be more cautious, prioritizing stability and adherence to established procedures. Finally, there's the expertise of CEOs David Calhoun and Elon Musk. SpaceX CEO Elon Musk criticized Boeing CEO David Calhoun, accusing him of lacking the expertise needed to lead an aircraft company. Musk argued that the CEO of an aircraft company should know how to design airplanes, not spreadsheets. Indeed, this is a reasonable argument, considering Calhoun has a bachelor's degree in accounting from Virginia Tech, but lacks any technical background. This becomes even more prominent as Boeing struggles to bring its Starliner spacecraft back from the ISS due to a helium leak affecting its propulsion systems. In other words, Boeing's not only struggling significantly with its aviation electronics division, but even its cursed spacecraft project continues to face difficulties. Perhaps Elon's right in suggesting that a new leader has been needed for quite some time. Under Calhoun's leadership, Boeing's faced multiple crises, including two 737 MAX 8 plane crashes that resulted in 346 deaths and an emergency landing due to a cargo door that popped open. Since then, several whistleblowers have come forward, accusing Boeing of lacking safety standards. Calhoun's now resigned, with many agreeing Musk and Boeing need a leader with technical skills. Emirates President Tim Clark has said Boeing needs a strong technical leader and a governance model that prioritizes safety and quality. However, finding a new head capable of addressing Boeing's many challenges is not an easy task. Several candidates have declined Boeing's offers, reflecting the tough mission ahead. But ultimately, Robert Kelly Ortberg, a longtime aerospace veteran, has taken on this new role starting August 8th. It remains to be seen how Ortberg will adjust to Boeing, so for now we'll wait and see. Either way, NASA will fully support Boeing, as it does not want SpaceX to dominate the launch market. Officials don't want SpaceX to win contracts without competition, and they are also providing opportunities for other entities to participate in major programs. However, the bottom line here is that most are struggling to meet the fixed-price contract requirements, or if they do, their performance is unlikely to surpass SpaceX. The shift from traditional cost-plus contracts to fixed-price contracts helps NASA save money by eliminating cost overruns and delays, thus stimulating the market. This means that suppliers can own the vehicles and sell the vehicles to various entities, including NASA. However, the timing of this effort is quite sensitive, as the aerospace industry is only just entering the commercialization phase. Major traditional aerospace contractors like Lockheed Martin, Boeing, and Northrop Grumman are very familiar with cost-plus contracts, which give them time and financial freedom. In particular, Boeing's Wall Street-style leadership often prioritizes profit over quality and reputation, making traditional contracts their goldmine. Therefore, it's understandable that this change may weaken those companies, leading them to reassess their participation in future fixed-price contract competitions. Northrop's CEO, Kathy Warden, stated in August last year, "We are becoming even more disciplined in ensuring that we work with the government to use fixed-price contracts appropriately." Another area of potential interest is the private companies that NASA is eyeing. They're hopeful that these new unicorns with innovative mindsets will thrive in the fixed-price contract environment. Ironically, the rocket market is incredibly tough, and any new company will need wealthy backers to heavily subsidize their operations, like Blue Origin with Jeff Bezos or SpaceX with Elon. At the very least, they must demonstrate that the company will generate sustainable revenue to attract investors. Last but not least, they must have smart strategies to survive and thrive during this harsh transition period, creating significant differentiation from long-established traditional companies. SpaceX's approach represents the most complete and up-to-date understanding of how to launch rockets effectively. Thanks to this, SpaceX is thriving within NASA's commercial space ecosystem. To catch up with SpaceX, these unicorns can leverage the advantage of being successors by observing Falcon 9 and learning how it's done. Standing on the shoulders of giants is also a strategy SpaceX employed during its early wild days by learning from NASA's Space Shuttle program how to build heat shields, analyze failures, and implement appropriate solutions. However, to break SpaceX's dominance, the key is not to compete with them on their own terms. Someone should do something fundamentally different, although this doesn't always guarantee success. This is where startups with unique ideas come into play, like Spin Launch with its massive accelerator technology, or Sierra Space with its mini space shuttle Dream Chaser. As for Boeing's Starliner, it has become outdated and lacks the power of competition. Perhaps NASA is still favoring Boeing's Starliner in order to only protect its own reputation. 10 years ago, NASA contracted billionaire Elon Musk's relatively new rocket company and Boeing to create a commercial space taxi market. The agency paid SpaceX only $2.6 billion, and the latter got $4.2 billion. At the time, it made sense to award Boeing a heftier contract. The company had already begun work on a spacecraft and had experience working closely with NASA, going all the way back to the Project Mercury in the late 1950s. Those close ties were reiterated as recently as a month ago by Dana Weigel, NASA's International Space Station program manager, who reminded reporters about Boeing's role in the space station itself. "This isn't the only Boeing-built spacecraft we'll operate from Houston's Mission Control," she said. "We are looking forward to Starliner, but we're also really proud to be operating the ISS, which is the longest continuously operational spacecraft in human history." Once the agency retired the shuttle in 2011, NASA was forced to tag along with Russian Soyuz rockets from Kazakhstan to get their crew into space. That might have been fine, but the U.S. was paying upward of $86 million a ride. We've not had the friendliest of relationships with Russia, particularly recently, and the head of their space agency said, "Well, NASA can get itself a big trampoline." Sven Billen, an aerospace engineer professor at Penn State, said, "As an American, the inability for us to get to space on our own spacecraft was, to me, an embarrassment." The need for Russia to get Americans to space ended when SpaceX's Crew Dragon paused all its tests for certification, but NASA never intended to have all its eggs in Elon's basket. After the Columbia disaster, it took 2.5 years for the U.S. to return to spaceflight. The agency has wanted at least 2 vendors, so there's always a backup if the FAA grounds one for any reason. Their position on the issue remains, even as the space station nears retirement in 2031. The need for Plan B became clear last year when a leak on the station forced NASA to consider a contingency of loading all the astronauts in one SpaceX spaceship to get home, should an emergency evacuation be necessary. If something happens to Dragon, God forbid, then we're back to asking the Russians for rides, Byland said. I'm not sure that the American public has the stomach for that. That's all for today's episode. Thanks so much for watching, and see you next time.